Hi there everyone, welcome to this lesson on solving quadratic equations. In this lesson, we want to look at factorization and more specifically at the zero product rule, difference of squares, common factors, and the cross method. Let's start by looking at what we mean by a quadratic equation. A quadratic equation is an equation in the form ax squared plus bx plus c equals 0, where a, b, and c are constants and x is a variable or unknown. The values of x that make the equation 0 are known as the zeros or roots of the equation. Factorization is a method for finding the zeros or roots of a quadratic equation. We will also be using the zero product rule, which says if a times b is 0, then either a is 0 or b is 0. So example 1a here deals with using the zero product rule. Now remember that the zero product rule says if a times b is 0, then a is 0 or b is 0. Let's see how we can apply the zero product rule to solving each of these equations. So let's have a look at a. In a we have x minus 3 times x plus 2 is 0. Here x minus 3 will represent a in the zero product rule, and x plus 2 will represent b in the zero product rule. Then applying this rule, we can say that a is equal to 0. In other words, x minus 3 will equal 0. Or b is equal to 0. In other words, x plus 2 must be 0. And now we simply solve for x in each of these two equations. Here we can take the negative 3 to the right-hand side. So x will equal positive 3. In other words, the sign will change. And here we can take the positive 2 to the right-hand side. In other words, x will equal negative 2. Let's look at the second example. Here we have 2x plus 3 times 3x minus 5 equals 0. In this case, the 2x plus 3 will represent a, and the 3x minus 5 will represent b in the zero product rule. Applying the rule then for b, either a is going to be 0. In other words, 2x plus 3 will be 0, or 3x minus 5 will be 0. In other words, b will be 0. And in solving for x again, here we can take the 3 to the right-hand side. It becomes negative 3. And now we can divide the 2 into the right-hand side. So we see that x is negative 3 over 2. Here we can take the negative 5 to the right-hand side. It becomes positive 5. And then we can divide the 3 into the right-hand side. So we see x is equal to 5 over 3. So our final answer then is x is negative 3 over 2, or x is 5 over 3. Then looking at c, we have x times x minus 4 equals 0. We don't have brackets around the x, but here the x will represent a, and the x minus 4 will represent b. So a times b is equal to 0. That means either a is 0, in other words, either x is going to be 0, or b is 0. In other words, x minus 4 is 0. So x is 0, or x minus 4 is 0. And here we can solve for x, and we see that x is equal to 4. In other words, our final answer is x is 0 or x is equal to 4. Then finally, let's look at D. Here we have x squared equals x, and we need to solve for x. So let's have a look at this. So we have x squared equals x. Now, the first thing we do is to bring everything to the left-hand side. So we bring this x to the left-hand side. Now we can factorize the left-hand side by taking out a common factor, which is x in this case. So x into x minus 1 equals 0. Now note, if we multiply out again, we're going to end up again with x squared minus x, because x times x will give us x squared, and x times negative 1 will give us negative x. Now we can use the zero product rule. The x here will represent A, and the x minus 1 will represent B. So if A times B is 0, then either A is 0, in other words, x is 0, or B is 0, in other words, x minus 1 is 0. And we can solve for x in the second equation here by taking the negative 1 to the right-hand side. So we find x is equal to positive 1. So the final answer here will be x is 0 or x is positive 1. So let's look at your answers to this question. In A, we have x plus 7 times x minus 1 equals 0. So using the zero product rule, we know that x plus 7 must be 0, or x minus 1 must be 0. And now we can solve for x in each of these two equations. Here we can take the 7 to the right-hand side, and it becomes negative 7. And here we can take the negative 1 to the right-hand side, and it becomes positive 1. So then the final answer is x is negative 7 or x is 1. Let's look at B. So B, we have 3x plus 1 times 4x minus 5 equals 0. Once again, using the zero product rule, 3x plus 1 must be 0, or 4x minus 5 must be 0. We can solve for x here. We can take the 1 to the right-hand side, and it becomes negative 1. And now we can divide the 3 into the right-hand side, and we find that x is equal to negative a third. Here we can take the negative 5 to the right-hand side. So 4x equals positive 5, and we can divide the 4 into the right-hand side. So x is 5 over 4. Let's go to C. We have 2x times x plus 3 equals 0. So once again, using the zero product rule, 2x is equal to 0. So 2x equals 0. Or what's inside the brackets, which is x plus 3, must be 0. We can isolate x on the left-hand side here by dividing the 2 into the right-hand side. So x is 0 divided by 2, which of course is 0. And here we can solve for x by taking the positive 3 to the right-hand side. So x is negative 3. Let's look at the last one. We have 5x squared equals 2x. We can start by bringing everything to the left-hand side. So then 5x squared minus 2x will equal 0. Now we can take out x as a common factor here. So x into 5x minus 2. You have to make sure that you get back what you started with when you multiply out. X times 5x will give us 5x squared, and x times negative 2 will give us negative 2x. Now we can use the zero product rule. So x is 0, or what's inside the brackets, which is 5x minus 2, is 0. And here we can solve for x. We can take the negative 2 to the right-hand side. It becomes positive 2. And we can divide the 5 into the right-hand side. So then x will equal 2 over 5. So x is 0, or x is 2 over 5. Let's look at your answer to this additional question. So we have P times AX plus B times CX minus R is equal to 0. And we are also told that neither P nor A nor C is equal to 0. We can use the zero product rule. We know that P is not equal to 0. So either AX plus B must be 0 or CX minus R must be 0. Now we solve for x in each of these equations. Here we can take the b to the right-hand side. Since a isn't equal to 0, we can divide a into the right-hand side. So that means that x is equal to negative b over a. Here we can make x a subject as well. So we can take the negative r to the right-hand side. And then we can divide c into the right-hand side. So x equals negative b over a, or x is r over c. So example 1b deals with quadratic equations in the form ax squared plus c equals 0. In other words, when we take the standard quadratic form, ax squared plus bx plus c equals 0, and b is equal to 0, then the middle term here vanishes, and we end up with this form, ax squared plus c is equal to 0. So we want to look at how to solve an equation in this form. And we're basically going to use a difference of squares. Now, recall for a difference of squares, if we have a squared minus b squared, then we can take the square root of the first term, which is a, then minus the square root of the second term, which is b, in one set of brackets, and then multiplied by a plus b. So a minus b times a plus b gives a squared minus b squared. So let's look at this example. It says solve for x in each of the following equations. And in A, we have x squared minus 4 equals 0. So we need to solve for x. So it's x squared minus 4 equals 0. And we can see that this is a difference of squares because the first term is a perfect square. Then we have a minus and the second term is a perfect square. So then we can apply the difference of squares. So then the square root of the first term is x. Then minus the square root of the second term is 2. So x minus 2 in brackets. And then times x plus 2. And this must be 0. Now we can use the zero product rule. So the first set of brackets, or the contents of the first set of brackets, must be 0. Or the contents of the second set of brackets must be 0. Now we solve for x in each of these equations. So the negative 2 can go to the right-hand side, and we have x is equal to 2. And here the positive 2 can go to the right-hand side, and we have x is equal to negative 2. Now, I just want to add that there's an alternative way of solving this type of equation. So let's look at that. Basically, we can take the constant, in this case negative 4, to the right-hand side. So x squared will equal 4. And now we can take the square root on the right-hand side. Now, remember that when we take the square root on the right-hand side of an equation, the answer will always be plus or minus. So x equals plus or minus the square root of 4, which is 2. In other words, x is equal to negative 2, or x is equal to positive 2. You can decide which method of these two you want to use. Let's continue to B. We have 2x squared minus 18 equals 0. So 2x squared minus 18 equals 0. The problem with using the difference of squares here is that the first term is not a perfect square. 2 is not a perfect square. And the second term is also not a perfect square. However, let's see what happens when we divide through by the common factor, which is 2. So the 2's will cancel here, and we're left with x squared. 18 divided by 2 is 9. So x squared minus 9 is 0. And now we do have a difference of squares. Both x squared and 9 are perfect squares. So we take the square root of the first term, which is x, minus the square root of the second term, which is 3, and then multiplied by x plus 3. Now we can use the zero product rule. In other words, x minus 3 is 0, or x plus 3 is 0. And we solve for x in each of these equations. So x will equal positive 3, or x will equal negative 3. Let's look at the alternative method here. We can take the negative 18 to the right-hand side. So 2x squared will equal positive 18. Now we can divide the 2 into the right-hand side. And we take the square root on the right-hand side. So remember, it's going to be plus or minus. X is going to be plus or minus the square root of 9. In other words, plus or minus 3. So this means that x is either negative 3 or x is positive 3. Let's move on to C. So here we have x squared minus 7 equals 0. Once again, we have the problem that x squared minus 7 is not a difference of two squares. So we can't factorize it as such. 7 is not a perfect square, so this is not a difference of two squares. We can use a simple law of surds and turn this into a difference of squares. The law of surds that I'm referring to is that the square root of a all squared is equal to a. So we can apply this law to the 7 over here, and we can rewrite the 7 as the square root of 7 all squared, because we know that this is going to give us 7 again. Now we have a difference of squares, and we can factorize it as such. So the square root of the first term, which is x, minus the square root of the second term, which is square root 7, then times x plus the square root of 7. Then using the zero product rule, we know that x minus the square root of 7 must be 0, or x plus the square root of 7 must be 0. And then solving for x is equal to the square root of 7, or x is equal to the negative square root of 7. And of course we can solve this on a calculator, correct to 2 decimal places. So the square root of 7 here is 2,64 or 2,65. So let's use 2,64. So x is 2,64 or x is negative 2,64. Then of course we could have used an alternative method. So going back to the original equation, we could have taken the negative 7 to the right-hand side. So x squared would be positive 7. And now we can take the square root on the right-hand side, and we get plus or minus the square root of 7. And then that means that x is plus or minus 2,64. So we basically get the same answer. Let's look at the last equation here. So D. So we have 2x minus 1 all squared equals 9 over 16. And we need to solve for x. Now, this equation is a little bit more complex than the previous ones. What we can do here is we can let what's inside the brackets, in other words 2x minus 1, be equal to k. And we can rewrite this equation in terms of k. So then k squared will equal 9 over 16. Now we can bring the 9 over 16 to the left-hand side. So k squared minus 9 over 16 equals 0. And we have a difference of squares. So we can factorize it. So k minus, so the square root of the first term, which is k, minus the square root of the second term. The square root of 9 over 16, of course, is 3 over 4. So k minus 3/4 times k plus 3/4 must be 0. And solving for k minus 3/4 must be 0, or k plus 3/4 must be 0. This, of course, is using the zero product rule. So solving for k, we can take the negative 3/4 to the right-hand side. And here we can take the 3/4 to the right-hand side. Of course, we were asked to solve for x. So now that we have the two values for k, we need to bring back the x's. Remember we said 2x minus 1 is equal to k. So then 2x minus 1 must equal 3/4, or 2x minus 1 must be equal to negative 3/4. We can solve for x. We can take the 1 across. So then we'll get 1 3/4 on the right-hand side. Now, 1 3/4 we can write as 4 times 1 is 4, plus 3 is 7. So 7 over 4. So 2x equals 7 over 4. And here we can take the negative 1 to the other side. And we're going to end up with 1 minus 3/4. And that of course is 1/4. So 2x here will equal 1 minus 3/4, which is 1/4. Now we can divide the 2 into the right-hand side. Now 7 over 4 divided by 2 is 7 over 8. Of course, you could do this on a calculator. And here, 2 into 1/4. 1/4 divided by 2 is an 1/8. Once again, we could have done it differently. So let's look at that. Here at the beginning, we could have taken the square root on the right-hand side. In other words, we could have said 2x minus 1 is plus or minus the square root of 9 over 16. So this is plus or minus 3/4. And in taking the 1, or the negative 1 rather, to the right-hand side, so it's 1 plus or minus 3/4. And we can isolate x, but first let's work out what 1 plus or minus 3/4 is. So first 1 plus 3/4. Of course we saw that that was 7 over 4. And in 2x will equal 1 minus 3/4, which is 1/4. Now dividing the 2 into the right-hand side, we get the same answer as before. So 7 over 8, x is equal to 7 over 8, or x is equal to 1 over 8. Let's look at your answers to this question. It says solve for x in each of the following equations. And in A, we have x squared minus 9 equals 0. So x squared minus 9 equals 0. Of course, this is a difference of 2 squares. Both x squared and 9 are perfect squares. So we can factorize it as such. So it's x minus 3 times x plus 3 equals 0. And now we can use the zero product rule. So x minus 3 is equal to 0, or x plus 3 equals 0. And solving for x, we see that x is equal to 3, or x is equal to negative 3. Let's look at the alternative way of doing this. Of course, we could have taken the negative 9 to the right-hand side. So x squared will equal positive 9. And then taking the square root on the right-hand side, x is equal to plus or minus the square root of 9, which is plus or minus 3. B is slightly more complex. Firstly, we don't have a difference of squares. A half is not a perfect square, even though x squared is, and 8 is not a perfect square. However, we should always try and get rid of fractions in an equation. So let's see what happens when we do that. So then B, a half x squared minus 8 equals 0. So then getting rid of the fraction here, we can multiply through by 2. And of course, the 2's will cancel here, and we're left with x squared minus, and 2 times 8 is 16. Now we have a difference of squares. So we can factorize it as x minus 4 times x plus 4 equals 0. And in solving, x minus 4 must be 0, or x plus 4 must be 0. So then x is equal to positive 4, or x is equal to negative 4. Once again, let's look at the alternative way of doing this. We could have taken the negative 8 to the right-hand side. So a half x squared would equal positive 8. Then, getting rid of the fraction, we can multiply through by 2. And we'll have x squared equals 16. Now we can take the square root on the right-hand side. So x is plus or minus the square root of 16, which of course is plus or minus 4. Then in C, we have x squared minus 3 equals 0, and we need to solve for x. So x squared minus 3 equals 0. This is not a difference of squares because 3 is not a perfect square. So we can use this rule of thirds again that says the square root of a all squared is equal to a, in order to turn this into a difference of squares. So then we can rewrite the 3, so x squared minus the square root of 3 all squared equals 0. Now this is a difference of squares, so we can factorize. So the square root of the first term minus the square root of the second term times the square root of the first term plus the square root of the second term. This must be 0. We can use the zero product rule. So x minus the square root of 3 equals 0, or x plus the square root of 3 equals 0. So then x is equal to the square root of 3, or x is equal to negative the square root of 3. Once again, we can work this out on a calculator to get the answer to 2 decimal places. So then the square root of 3 is 1,73, correct to 2 decimal places. Then, just looking at the alternative way of doing this, we could have taken the negative 3 to the right-hand side. So x squared is equal to positive 3. Now we can find the square root on the right-hand side. So x is plus or minus the square root of 3, which is plus or minus 1,73. Then lastly, we have x plus 2 all squared equals 1. So x plus 2 all squared equals 1. We can let x plus 2 equal k. And then we'll have k squared equals 1. We can bring the 1 to the left-hand side, and we have a difference of squares. So k squared minus 1 is 0. Now we can factorize. So k minus 1 times k plus 1 equals 0. We can use the zero product rule. So k minus 1 is 0, or k plus 1 is 0. And in solving for k, k will equal positive 1, or k will equal negative 1. Now, remember that we said x plus 2 is equal to k. So that means that x plus 2 must equal 1, or x plus 2 must equal negative 1. And in solving for x, we can take the 2 to the right-hand side. 1 minus 2 is negative 1. And here, the positive 2 goes to the right-hand side. So negative 1 minus 2 equals negative 3. Let's look at the alternative way. So the alternative way is simpler. Basically, we can take the square root on the right-hand side. So x plus 2 is plus or minus the square root of 1. And the square root of 1, of course, is 1. So x plus 2 is plus or minus 1. Now I can take the 2 to the right-hand side. It becomes negative 2. So that means that x is negative 2 minus 1. In other words, negative 3. Or x is negative 2 plus 1, which is negative 1. So this example deals with solving quadratic equations in the form ax squared plus bx equals 0. In other words, quadratic equations in which the constant c equals 0. In this case, we use common factors to solve the equation with. So let's look at a. We have x squared minus 2x equals 0, and we need to solve for x. So x squared minus 2x equals 0. And this, of course, is in the form ax squared plus bx equals 0. So as we said, we're going to use common factors here. And we're going to take out a common factor of x in this equation. So on the left-hand side, we take out x. So it's x into x minus 2 equals 0. We have to make sure that when we multiply back in, we get the original left-hand side here. So x times x is x squared. X times negative 2 is negative 2x. Now we simply use the zero product rule. So x will be 0, or x minus 2 is equal to 0. And here we can solve for x. So x is equal to 2. In this case, the answer is x is 0 or x is 2. Let's look at b. We have 3x squared is equal to 2x. Now, let's just write this down. 3x squared equals 2x. Our first step here is to bring everything to the left-hand side. So we can bring the 2x to the left-hand side. And we have 3x squared minus 2x equals 0. Now we can take out a common factor of x. So it's x into 3x squared 3x times, and x into 2x twice. Once again, we must make sure that when we multiply out again, we get back to the original left-hand side here. So x times 3x is 3x squared, and x times negative 2 is negative 2x. Now we can use the zero product rule. So x will equal 0, or 3x minus 2 will equal 0. And we can solve for x here. We can take the negative 2 to the right-hand side. It becomes positive 2. And now we can divide the 3 into the right-hand side. So x is 2/3. The final answer then is x is 0 or x is 2/3. Then going on to C. We have 4x minus 5x squared equals 0. So 4x minus 5x squared equals 0. Once again, we can take out x as a common factor. So x into 4x, 4 times, minus x into 5x squared, 5x times. And this is equal to 0. Then using the zero product rule, either x is going to be 0 or 4 minus 5x will be 0. And solving for x here, we can take the 4 to the right-hand side. Becomes negative 4. And now we can divide the negative 5 into the right-hand side. Before we do that, we could actually cancel the negatives first on both sides. It's the same as dividing through by negative 1. So then we have 5x equals 4, and we can divide the 5 into the right-hand side, and we get x is 4 over 5. So then x is 0, or x is 4 over 5. Let's look at the last equation. So D so we have px squared plus qx equals 0, and p isn't equal to 0. So px squared plus qx equals 0. Once again, we can take out a common factor of x here. So x into px squared, px times, and x into qx, q times. We can check that we get back what we had at the beginning when we multiply out. X times px will give us px squared, and x times q will give us qx. Now we can use the zero product rule. So x will equal 0, x, or px plus q will equal 0. And here we can solve for x. We can take the q to the right-hand side. So px will equal negative q. Now, remember that we were told that p isn't equal to 0. And that means that we can divide by p. So we can divide the p into the right-hand side because it's not 0. So x will equal negative q over p. Recall that we're not allowed to divide by 0. But since p is not 0, we can divide it into the right-hand side here. So let's look at your answers to this question. In A, we have 2x squared plus 3x equals 0. And we need to solve for x. We can take out a common factor of x. So x into 2x squared, 2x times, and x into 3x thrice. Now we can use the zero product rule. So x is equal to 0, or 2x plus 3 equals 0. And we can solve for x here. We can first take the 3 to the right-hand side. And now we can divide the 2 into the right-hand side. So then x is 0, or x is negative 3 over 2. Let's look at B. We have x squared equals 7x. We can start by bringing everything to the left-hand side. Now we can take out x as a common factor. Then using the zero product rule, x is equal to 0 or x minus 7 is equal to 0. And solving for x here, x will equal 7. So x is equal to 0 or x is equal to 7. Let's look at C. We have 3x minus x squared equals 0. So 3x minus x squared equals 0. We can take out a common factor of x into 3x thrice, and x into x squared, x times. Then, using the zero product rule, x is equal to 0, or 3 minus x will equal 0. And we can solve for x here. We can take the 3 to the right-hand side. So negative x will equal negative 3. Now we can divide through by negative 1, and the negatives will cancel. And we end up with x equals 3. So x is equal to 0, or x is equal to 3. Let's solve the last equation. So D ax squared plus bx equals 0, and we are also told that a isn't equal to 0. So ax squared plus bx equals 0. Taking out a common factor of x here, x into ax squared, ax times, and x into bx, b times. Now we can use the zero product rule. So x will equal 0, or ax plus b will equal 0. And solving for x here, we can take the b to the right-hand side. So ax will equal negative b. And now since a isn't equal to 0, we can divide it into the right-hand side. So x will equal negative b over a.